by having different components that are kind of plug and play, allows them to have a lower cost, highly versatile system compared to having this design is only used for this thing, this design is only used for this thing. So I think there are other techniques that you can use to change your costing. We see similar diversity with the Japanese rockets to a certain degree. Many nations are trying to figure out how to have the side boosters, the core booster, and a variety of configurations to take them to varying degrees of medium lift and heavy lift. And I really am loving these plug-and-play kinds of designs that we're seeing that allow this diversity. So I think there's multiple techniques. And with heavy lift, like you said, you want to use every ounce of fuel you can to get off this planet.
Right. And so if the payload, if it's a $10 billion space telescope, for example, and the thing that matters is that you get this payload to precisely the right orbit, then spending $1 billion or $500 million on your launcher is worth it.
Yes.
But if you're trying to launch 40,000 internet satellites, then the economics change.
Yes.
Yeah.
Yes. And again, it also depends on what orbit you're getting to, because they aren't putting those 40,000 satellites up in GEO. They're putting them in low Earth orbit. And it takes a whole lot less fuel to get there.
Yeah. I mean, there are a lot of missions that have been proposed right now that there is just no launcher capable of doing it.
Yeah.
Even the Space Launch System with its Block 1 configuration couldn't do some of these missions. Things to the outer planets, heavier cargo to the moon, things like that. Like, you're going to need to get to the Block 2, the Block 2B, which is the heavier upper stage, before you can even pull off some of these bigger missions. Like, the SLS is amazing, but it's still not as powerful as the Saturn V.
And we won't have those additional heavy lift capacities until they turn on the factory lines to build the new RS-25 engines, to build the new casings and electronics for the SRBs.
Yeah.
They're still in the reuse stage. So this is where next week we are going to be taking a look at Starship. And this week we have to say there are other heavy lift vehicles in the process of being developed. Arianespace is looking at what they can construct. China is looking at what they construct. Russia, we're going to set them aside and say, we don't know what's going on over there.
Russia says a lot of stuff.
Right.
Yeah.
Right.
We don't take very seriously.
Yes.
But China has a lot of very powerful launchers right now, and even more powerful ones in the works for their missions to the moon. Yeah. It's I gotta come clean here, right? Like, I feel an enormous amount of. Can you have an enormous amount of ambivalence? I feel extreme ambivalence in this situation, because on the one hand, this next generation of reusable rockets don't exist, and we don't have the capability to go to interesting locations, and haven't had it for decades, maybe 50 years. That finally the SLS is the first rocket that will give us that capability. Falcon Heavy is kind of there, but SLS is the machine that would let you send out an interstellar probe or go to send a heavy.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio, AFM Radio.
welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Sana, and I'm joined by Gagan. Hi, Gagan.
Hey.
We are broadcasting live from the Allan Carswell Observatory located in York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western World, Quarks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. Universal time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 to 10 p.m. local Toronto time. Go to our website, observatory.info.yorku.ca, and follow the links to our OPV chat, or just visit our YouTube channel to join in. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have on our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can also always connect with us on Twitter, where our handle is @YorkObservatory, or on Instagram @YorkUobservatory, and finally on Facebook @Allan Carswell Obs, just to make everything confusing. All of our programs are free, but if you would like to make a donation, please see our website at observatory.info.yorku.ca. So tonight, the weather does not look so great, so unfortunately we don't have any live viewing to show you over on our OPV chat room, but we will be monitoring the chat room for questions. We also have staff over there who will chat with you about anything astronomy related, so please feel free to post in the chat room. Gagan, how are you tonight?
I'm good. It's been a long day in the lab, but everything's going all right. How are you?
I'm pretty good. I've been working a lot too, not in a lab like you, but we finally got our hands on that JWST data. So there's been a lot of fun stuff happening with that.
How does it look?
Oh, awesome. That telescope is just amazing.
No, I cannot imagine getting exclusive, just for me, JWST data. That is like Christmas Day every time that data comes through.
Oh yeah, we're getting, we currently only have a fifth of the data that we're getting. I'm because I'm part of the Canucks collaboration, so it's a guaranteed time observing program that my supervisor is part of, so put me in that too. So we're getting a bunch more, and we might actually get some more data on Christmas.
Oh my!
It falls, the window for those observations falls around Christmas, so might get another Christmas present there. But this stuff is so cool. I keep just going and like making images in DS9, making color images, and just zoom all the way in and just scroll around because it's really cool.
Yeah, that's so exclusive. Like, Sana, don't forget me when you're famous.
Yeah, I will definitely let you take a peek at some more of the data when we get it.
Yes, please. I won't tell anyone. Off air, of course.
It's definitely very cool.
All our listeners, please keep this a secret.
Yeah. All right. Well, we should probably get going with our This Week in Space and Astronomy History. We have a really great set of history items and awesome news items for you all tonight. So starting off with our history. So on November 28th, 1967, that's our first history item for today, which is the anniversary of the discovery of the very first pulsar. So just before I go into some of the science, I'll quickly talk about what pulsars are. Pulsars are just a kind of neutron stars. So these are the remnants of massive stars that they make when they die. They blow up in supernova explosions, and certain kinds of massive stars will produce neutron stars. Next to black holes, neutron stars are some of the densest objects in the universe. You have masses of maybe about, I think it's around 1 to 2 times the mass of our sun that's packed into this pretty tiny area. So they have diameters around the size of cities. basically. So very dense, very extreme objects in general. And pulsars are kind of a subclass of these neutron stars that are, believe it or not, even more extreme and more crazy than the neutron stars themselves. A lot of I think all neutron stars do rotate because there is some angular momentum left over from the star's rotation that's passed off to the neutron stars in the supernova explosion. But there are some neutron stars that rotate incredibly quickly, and these are called pulsars. Some of them have rotation periods of about like a couple of seconds, and some other ones, which are called millisecond pulsars, have rotation periods of milliseconds. Now, this really fast rotation rate causes a magnetic field, so it kind of moves around some of the stuff inside of the neutron star and creates this wickedly strong magnetic field that shoots poles of high energy particles out of the poles of the magnetic field. So it's basically these massive and very powerful jets that are coming out of the pulsar aligned with the axis of the magnetic field. Now, sometimes the axis of the magnetic field doesn't exactly align with the star's rotation axis. So this basically causes the poles of the neutron stars that have the jets coming out of it to spin around as the neutron star rotates. And it just so happens that a lot of these poles happen to kind of be aligned with the Earth. And what ends up happening is that when you have this pole that passes between the Earth's field of view, you'll see a pulse of radiation come from the neutron star, and then it goes away, and then the pulse comes back a second or so later, and it just kind of keeps repeating. So you end up with this repeating signal, these repeating bursts of radiation coming from the neutron star with whatever rotation period the pulsar has, hence the name pulsars. So currently there are thousands of known pulsars. It's a very interesting field, a really, really cool phenomenon. But all of these detections date back to the original first discovery of a pulsar in November of 1968. This pulsar is known as PSR B1919+21. I'm not 100% sure what those numbers stand for, but I have a feeling it has something to do with the date that it was first picked up. The detection was made by a then PhD student named Jocelyn Bell Burnell. She was using the Mullard Radio Astronomy the Mullard Radio Astronomy Observatory located near Cambridge. It's a radio telescope that she and several other students had been building and working with for their supervisor, Anthony Hewish. Anthony Hewish had planned to use this radio observatory to study quasars. But before he had a chance to study quasars, a other major discovery came out of this observatory, which was pulsars. The telescope had begun operations in July of 1967 while it was actually still under construction. And as one of the students working on the observatory, Jocelyn Bell's job was to basically operate the telescope and then analyze some of the data that came out of it. So kind of nowadays we rely a lot on computers to help us analyze data, but this was in 1967, so they weren't using that same kind of technology. And instead of doing her analysis on a computer, Jocelyn Bell actually had to analyze signals printed out on paper. The telescope signals were actually just literally printed out on paper. It produced nearly 100 feet of that paper every single day that she would go and analyze by hand. So definitely a very, very hard job. And through all of these hundreds to eventually thousands of feet of paper that came out of this radio observatory, she started noticing what she called a bit of scruff that was showing up in the data. It was this weird signal that was repeating every 1.3 seconds, and it always came from the same point in the sky. So definitely a very weird thing to see. So Jocelyn Bell didn't really know what it was, so she brought it to her supervisor, Anthony Hewish, and he didn't really know what it was either. They started trying to kind of rule out different sources to figure out where this was coming from. So they had ruled out a couple astronomical sources that they thought might cause that repeating pattern, and also some man-made sources like television signals or orbiting satellites that could interfere with the telescopes and create that bit of scruff. Eventually, they still didn't really know what it was, and jokingly labeled the signal LGM1 for little green men, kind of joking around that maybe this is an alien civilization that's trying to communicate with us by sending us this repeating signal, hoping that we pick up on it. Of course, that wasn't what it was, and I think it was just kind of a little joke about, oh, we have no idea what this is, so let's be kind of funny about it. They didn't really do anything with this discovery for a while because they weren't sure what it was, but by December of 1967, Jocelyn Bell continued to find these little weird things in the data from the radio observatory. She had detected 3 more similar signals that came from different areas in the sky, and that ultimately ruled out their joking little green men theory, since it was highly unlikely that 4 alien civilizations were using the exact same method to communicate with us. And in addition to ruling out that weird little green men theory, it also made them more confident that they had really found something new. So this wasn't just some weird thing happening with their data, some error in the equipment that was causing this weird bit of scruff, but it was actually some new astronomical phenomenon that everybody should know about. So they ultimately published their findings in February of 1968. They didn't say outright that this is a pulsar because they just hadn't figured that out yet. But after this publication, other astronomers started coming out of the woodworks and saying, hey, we found some similar things in our data too. At first, it had been ignored by a lot of astronomers because it was this weird thing and they had no idea what it was. But this publication by Jocelyn Bell and her supervisor, Anthony Hewish, sort of made everyone realize that, this isn't just some weird thing that's happening. Other people are picking this up too, and we should probably discuss what this is. Still, again, people didn't really know what it was at first, but eventually Thomas Gold came along, and in 1968, he showed that these signals were actually coming from these rapidly rotating neutron stars, which had already been theorized all the way back in 1933, but had not been detected or talked about at all until that original publication in February of 1968. So definitely a major discovery dating all the way back to November 28th, 1967. It was such a major discovery that they were actually awarded the Nobel Prize in 1974. And when I say they, I do not mean Jocelyn Bell Burnell. Part of the Nobel Prize went to her supervisor, Anthony Hewish, but she was not awarded the Nobel Prize, even though she had played an instrumental role in making this discovery. She was the one that found it in the data first, and then brought it to her supervisor's attention. But it has caused a lot of controversy about why she wasn't given the Nobel Prize. There is some people kind of defending it, saying, well, she was a student, she was a PhD student, and that's why she didn't get it, and it went to her supervisor instead. But I think there's always a kind of don't really know about maybe why she didn't get it, because she was a woman in astronomy and astrophysics in 1967. So don't really entirely know what to think about that one. But either way, very fantastic discovery, November 28th, 1967, by Jocelyn Bell Burnell and Anthony Hewish.
Yeah, you always have to wonder, if it was like a Joshua Bell Burnell PhD student, what would be the situation then? Mm-hmm. But I guess we'll never know now.
Yeah. The thing is that, interestingly enough, even though she didn't get the Nobel Prize, whenever I think who discovered a pulsar, the name that pops into my head is always Jocelyn Bell Burnell. Not Anthony Hewish, which is interesting.
No, it's like the not the same, but almost different. The whole thing with Watson and Crick. Mm-hmm. We don't really think about Watson and Crick. We think about Rosalind Franklin. Mm-hmm. With DNA. Yeah. Didn't specify. Sorry about that. But yeah, I have another theory. Is it possible that the little green men had already colonized much of space?
Yeah, and they were using the same method, hoping that somebody discovers them.
Yeah, they're just waiting for us to get the memo.
Yeah. Maybe astronomers are wrong and pulsars don't exist. It's all colonies of little green men.
It's all fake. This is just a scheme to distract us from the fact that aliens exist.
Exactly.
I must stress that was sarcastic. I trust the scientists.
Yes.
I need to disclaim that.
Yes.
All right.
Yes.
So
Well,
I think I'm up next.
yes, you have a great one coming up next.
We love our old planetary history. So December 3rd, 1973 is where I'm taking you all back today. And this is when Pioneer 10 becomes the first craft to reach Jupiter. And Pioneer 10 is, of course, a familiar favorite. It was launched back in March of 1972, so just over 50 years ago. And it was the very first mission to get to Jupiter and the first one to reach the escape velocity to leave our solar system. So it was an unmanned probe. Of course, we haven't sent people to Jupiter. I think that would have been bigger news. So Pioneer 10's main missions were to investigate the interplanetary medium, as nothing had really gone past the asteroid belt before. So it was the first probe to pass the asteroid belt and therefore reach Jupiter shortly thereafter. And it did that about 49 years ago next week on December 3rd, 1973. And through Pioneer 10, we got the first ever images of Jupiter back that were taken by a probe. So we had not gotten any close-up pictures of Jupiter before then, of course, because nobody had gone there. And we also got pictures of its moons Ganymede and Europa. We got to know a lot of the terrain that was around Jupiter, as well as its whole planetary system, or moon system, lunar system around it. We also found out a lot about Io and also the hydrogen cloud atmosphere that's kind of surrounding it, and other things about Jupiter and its four main moons in their orbits. Unfortunately, there were a lot of connectivity issues with image transmission, and we lost a lot of images of Io and Jupiter. So the only images that we have remaining are some of the Jupiter images, as well as the moons Ganymede and Europa. And we actually did get a close-up image of the Great Red Spot. So that was the first time we'd ever seen that in any detail. And Pioneer 10 is actually just still out wandering space. It has been going for a long time now, and assuming it was not hit by anything and it was not kind of knocked off course, it will be reaching the star Aldebaran's general vicinity in only about 2 million years. Not that long. We don't have much longer to wait. Aldebaran is 68 light years away, so it's not your average weekend road trip. But unfortunately, we also lost comms to the spacecraft in 2003, and that was our last communication, was like a really faint ping from it just to let us know its location. Even though it is probably the oldest probe that was launched to the outer solar system, it is no longer the farthest human-made object. Voyager 1 overtook it in 1998, which is crazy because Voyager 1 is not that. It's quite a bit younger than Pioneer 10. And Voyager 2 will actually take over second place in the farthest human-made objects next year. So Pioneer 10, although it was the oldest, it's not the fastest. The Voyagers outstrip it by miles. And but we are thankful for it. We've got a lot of really cool data. It has rightfully earned the name Pioneer as well as its successors. So a great mission to look back to.
I really love all of these interstellar missions. I think probably out of at least most of the probes that NASA and other space agencies have sent out into space, some of the Pioneer and Voyager missions have got to be just the best because they do so many things. They study planets, the outer solar system, and some of them you're still in contact with, even though Pioneer 10 isn't one. It's just they always significantly outlast their original mission timelines and do so much more. So they're really, really great missions.
Yeah, and it is really wild to me that space agencies were putting out these types of probes that were this durable and this successful in the 70s. And 50 years later, I mean, we've gotten some great probes since then. We had Cassini, we've had Juno. And, well, I guess we need time to build the legacy, but it kind of makes me sad. I want to know if we really funded space travel as much in the 90s and 2000s. I wonder how far we could be now, because clearly the science was ahead of its time.
Mm-hmm. Yeah, I mean, even like the this is always kind of the thing that was disappointing is how the Apollo missions ended, and how, which you're going to talk about later, Artemis now, which is great that we're finally getting missions to the moon again now, but come on, like 50 years. If Apollo had been such a good starting point for lunar exploration, if NASA had kind of been able to keep up the pace, if they'd had the funding to do that, imagine where we would have been now. It's pretty unfortunate, but still.
Yeah, it was kind of like, okay, the moon was the big goal, and instead of looking past to future targets, it was like, all right, wash our hands, let's go.
Mm-hmm.
The moon is done. We have conquered the solar system.
Yeah. Yep.
Yeah. So I mean, we could have been on Mars in the 90s. Who knows?
Yeah.
But we won't speculate, because we do have big things on the horizon right now, which we'll get to soon, not to keep you all in suspense. But Sana, how about you grab the last This Week in History before we move on to our exciting news?
Yeah, so this is December 2nd in 1995, another incredibly successful mission, which was the launch of SOHO. With SOHO stands for the Solar and Heliospheric Observatory. It was a joint, and still is, a joint mission between ESA and NASA, so the European and the American space agencies. And as the name of the spacecraft suggests, it was basically meant to study the sun. It had three main mission goals, or science goals, which was to study the sun's atmosphere, its internal structure, and also to observe kind of the environment surrounding the sun, which includes some of the stuff going on in the surface, like solar winds and coronal mass ejections, and all of that really cool but kind of scary stuff. So SOHO was originally meant to last for, I think it was only 2 years, but even now in 2022, over 25 years after the launch of the spacecraft, it's still in operation, and it has no signs of slowing down. Not all of the instruments on the observatory are still working or still in operation, but it's still going. It even has a mission extension up until 2025, at which point NASA and ESA will sort of reassess the mission, whether or not they want to continue providing funding. But either way, it is the longest running space-based solar observatory, which is completely insane. SOHO itself, in its several decades in space, has led to lots of very interesting discoveries about the sun and its environment. I think some of the best observations that it has taken are these long-term observations of the sun. So the sun has this 11-year solar cycles, where the activity on the sun ranges from very active to less active. We are currently approaching a solar maximum, which is the period of peak activity. So there's a lot of stuff happening on the surface. There's a lot of solar coronal mass ejections and lots of activity with solar wind, a lot of sunspots on the surface. So if you like observing the sun, this is definitely the time to do it. One of the interesting things about the solar cycle is that a lot of the processes that lead to this 11-year cycle is still a mystery. Astronomers have some ideas about what causes this 11-year solar cycle, but it's kind of a hard thing to study because the cycle is so long. So if you want to get reliable information on the solar cycle, you have to be observing the sun continuously for long periods of time in order to kind of get good data, get good information on what is causing this solar cycle. And SOHO is one of those observatories that can provide this quality information about the solar cycle, just because it's been in space and observing the sun for so long. So it's observed 2 of the 11-year solar cycles, and it's continuing those observations. So it's going to be observing another solar maximum in the next few years. And these, like I said, these long-term observations are very critical to being able to study the solar cycle in depth, just because it's so long. So SOHO is amazing in that respect, with the data that it's been able to provide on the solar cycle. It's also studied some more smaller scale activity on the sun. So it's observed in total 20,000 coronal mass ejections. This is a pretty important thing to observe, not just because you can learn about coronal mass ejections, but also because if a coronal mass ejection is flung at the Earth, it can cause significant damage. So things like electrical grids and the internet will be severely affected. It could cause billions of dollars in damage if a coronal mass ejection were to hit us. But thanks to SOHO and some other solar observatories in space, they can actually observe these coronal mass ejections several days before they hit the Earth, which is enough to take some kind of action on Earth to prevent horrific damage. I don't think it's completely perfect, but it's still it's better than no notice. So observatories like SOHO can also really help us in the event of some catastrophic Carrington event level coronal mass ejection. On top of that, SOHO's influence has extended beyond just the sun, because it's observed almost 3,000 comets, which is about half of the known comets in our solar system. This might seem a little counterintuitive that an observatory meant to study the sun studies comets, but it's actually a really interesting reason why it can do this. So some of the instruments on SOHO actually block out the light from the sun, just kind of like like the moon does in solar eclipses. But in the case of SOHO, it blocks out the light from the sun so that it can study the dimmer corona that's around the sun. And this means that it can find dim things that surround the sun, like comets. It also, another reason why it can observe so many comets is because when comets get close to the sun, they get really bright. There's more solar radiation and solar wind that's hitting them, so they start to really, a lot of the stuff on their surface starts to evaporate. They really start to light up. So you have a higher chance of observing the comets when they are close to the sun, which means that SOHO can actually find a lot of comets that are coming close to the sun. So it's definitely done a lot of work both in studying the sun and some other interesting things in our solar system. So like I had said before, not all of the instruments on SOHO are currently active. It has 12 instruments on board, but only one of them is in use, which is called the Large Angle Spectrometer Coronagraph, which is used to predict space weather. So things like coronal mass ejections and solar wind, things that would possibly have an effect to us on Earth in kind of immediate time periods. So yeah, there was a great launch anniversary to SOHO. And just want to mention this, that all of the data from SOHO is accessible on NASA's website. So if you would like to see what the sun looks like right now, you can actually look it up, not only from SOHO, but from other solar observatories that NASA runs as well. So definitely a very interesting mission.
Yeah, enough time for me to put on all my sunscreen that I need for this.
Yeah, these solar storms are kind of scary, and I really hope we don't get hit with one during the solar maximum.
Yeah, the only positive I can think we might glean from this is like beautiful aurora. But, you know, if you're not going to stare right up at the sky every night, which is probably not a good idea at that time.
No.
You probably won't see them.
Yeah.
But yeah, and we use the SOHO database for the first year astronomy project at York, don't we?
Yes, we do. You can.
Yeah.
If you're curious, what we would do in our first year astronomy courses is look up around your birthday, in some year around solar maximum, look up images of the sun over about a week or so, and then you can actually, based off of the motion of the sunspots, calculate the rotation period of the sun at the equator and also closer to the poles, because the rotation periods are different at those two locations. So it's definitely a fun project.
Yeah, and the fact that you have to do it on your birthday can't cheat off anybody else. Everybody has their own sunspots that they're working on.
Yeah.
It's a good time, but it's fun.
Definitely.
Yeah, I remember that one.
Yeah. All right, so that is 9:30. We're exactly halfway through. So we actually finished this week in space and astronomy history on time, which I think is a record for us and maybe for your universe in general, because we always go over.
Yeah, we only had to cut our material in half.
Yeah. Yep, pretty much. But you know what? Let's take the win. We finished on time.
We take the win.
Yes.
All right.
Yes, and just for those of you who are just tuning in, you're listening to York Universe, broadcasting live from the Allan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. Please visit our website, observatory.info.yorku.ca, to head over to our online public viewing chat room. We're showing some archival images because the weather is not clear right now, but we also have a chat room, so we're monitoring the chat room for any questions, and we also have observatory staff over on the OPV chat as well, who will answer any questions that you might have. So I'm Sana, and you've been listening to me and Gagan. We're just finishing up discussing some astronomy history, 3 very interesting things. And we, coming up, have some interesting news stories for you as well. But before we get to our news items, we should go over a few reminders. And Gagan, you're first up.
Yeah, so this Wednesday, our weekly Teletube is broadcasting, and it's actually a special guest speaker this week. So Dr. Adam Frank will be giving a talk on the search for alien life in the universe. And this will be on our YouTube channel. So tune into our YouTube channel and visit our website, observatory.info@yorku.ca, for further details. Our YouTube channel is at Yorku Observatory, and we do a Teletube every Wednesday night, and it's a different topic every week with different speakers. So tune in for whatever weekly discussion you want to listen to. And weather permitting, we even have some possible live imaging from our 1-meter telescope. So, check the skies, check the weather in Toronto, see if you want to get some live images of the sky. And we'll be able to have some nice dark skies now, because it now gets dark just after noon in Toronto. That's incorrect. That was sarcasm again. But it gets dark around like 5 o'clock. So we have lots of nighttime observing time.
It's definitely weird looking out at 5 p.m. and having it be dark. I'm absolutely loving it from an observing perspective, but it's definitely weird.
From like a seasonal depression perspective, it's like abysmal, but it kind of balances out because extra telescope time, not as much sunlight, does that make up for my lack of vitamin D? I don't know, but I'm going to pretend it does.
Yeah, and the university is also putting the dome up over the Lions Stadium located right beside us. So we don't have to worry about their lights creating the artificial sun at night anymore, which is also a perk of the winter time.
I'm so happy they did that.
Yeah, I've been seeing them. They've kind of been rolling out the dome over the past few days, and I don't know if they've inflated it yet, but I've been kind of watching it from Petrie because you can see it. So they've been out there putting that up.
It should be up this week, I think.
Yeah, hopefully. Yeah. And in other observing news, this is probably something that's also going to be talked about next week, but I figured I would mention it this week anyways, because you can still kind of observe it. Mars is approaching its opposition on December 8th. Just because the opposition itself is on December 8th doesn't mean that you can't observe Mars now. It has been looking very beautiful and red in the night sky. I've been seeing it almost every night. I just kind of have to wait, depending on what altitude you can observe at. Wait a little bit after sunset, and you'll be able to take a look at Mars. If you wait a little bit longer into the night, closer to around midnight or 1 in the morning, you'll also start to see the constellation Orion rise, and it is not all that far away from Mars, at least for right now. So I'm a little bit biased here because Orion is my favorite constellation, but Mars, the red Mars and red Betelgeuse in Orion just look fantastic close to each other. So this is definitely a good time to do some Mars observing when it's approaching opposition on December 8th. Yeah, okay, so I think those are our reminders for tonight. We're making very good time once again. And we'll move on to our news items. So we're going to be discussing Artemis in just a little bit, which is a ton to talk about there. But a slightly silly news item I have before that is the latest edition of astronomers naming things after food. So I don't know how many people know about this, but astronomers have a habit of using food when they're naming things. So there are certain classes of galaxies that are very close to us, which are called green peas, blueberries, and purple grapes, just because they look either green, blue, or purple, depending on the filters that you observe them in. And also because they're these little tiny nuggety things, so they can be compared to green peas and blueberries and purple grapes, which are all very small. Another kind of galaxy are called hot dogs, hot dust-obscured galaxies. You can describe white dwarf stars as the hot potatoes of our universe, because all they really do is sit there and radiate away their energy like hot potatoes. Massive stars that are dying can be compared to onions because they have a bunch of different layers with different material in the star. Of course, you also have spaghettification, which describes what happens when something gets too close to a black hole. It gets spaghettified, so kind of stretched out into these spaghetti-like things because of the differential forces of gravity near the black hole. And you also have, I think one of my favorites is nuclear pasta, where you can describe the interior of neutron stars as pasta. So different kinds of matter in neutron stars look different. So you can have lasagna-like noodles or spaghetti-like noodles that kind of look like the matter inside neutron stars. And just, I think this was last week or so, there is now a new thing to add to this list, which is neutron stars as chocolates. This is definitely a silly name, but the research is very interesting. The research itself was just studying the interior structures of neutron stars. And it turns out that the interiors of neutron stars can be defined as kind of these cosmic candies, because the structures are kind of set out in two different ways, depending on the mass of the neutron star. So lighter neutron stars, masses of about less than 1.7 solar masses, are kind of like chocolate pralines. They have these soft shells and these stiff cores. So the core is kind of like the hard hazelnut core surrounded by soft chocolate on the outside. But then if you go to neutron stars with masses greater than 1.7 solar masses, they have these stiff mantles and these soft cores, so they're kind of like chocolate truffles. So definitely a kind of silly naming convention, or silly comparisons here, but definitely very interesting. The research itself is pretty cool because neutron stars have just, the cores of neutron stars at least, have just been very hard to study over the years. The conditions are so extreme in neutron stars that they really can't be recreated on Earth. And the only way to make these sort of discoveries is pretty much to use simulations and these equations of state of the interior of neutron stars. These equations of state just kind of describe things about the neutron stars, like the temperature, density, and pressure inside them. And you can have equations of state for many, many different objects in the universe, including stars that are alive. So kind of stars like our sun each have their own unique equation of state. So what this research group did was they basically used some observations from either direct observations or theoretical models for nuclear physics to look at how sound waves propagate through the neutron stars. This is actually a very common technique for studying many things, including studying the interior of the Earth itself. Different materials have different compositions, exist in different states, and that all changes the way that sound waves propagate through them. So like sound waves propagate differently through air than they do through water, than they do through solid material. And based off of that propagation and how quickly they propagate, you can figure out the composition of an object. So the research group kind of took measurements from some observations and from some theoretical calculations, incorporated those observations into their equations of state for neutron stars. They had over 1 million different equations of state for these neutron stars, and they ended up working through that to discover what the interior of neutron stars look like, which is how they discovered lighter neutron stars look like chocolate pralines and heavier neutron stars are like truffles. So this is a really interesting result because it is something that really hasn't been done that much before. And it also tells you some very interesting things about neutron stars themselves. So it tells you how compressible the cores of the objects are. And it can also tell you more about the way that neutron star mergers produce gravitational waves. So when you have two neutron stars or a neutron star and another object that are kind of orbiting each other, when they merge, they can produce this very powerful burst of gravitational waves, which will rely on kind of the equation of state of the system and how compressible that material it is, if it can be sort of malleable. I think that might be the right word. But it's very interesting results because it will tell you the kinds of gravitational waves that these neutron star mergers will predict. So definitely very interesting research coming out of this, these cosmic candies. And another great example for me to talk about when I tell people about how silly and how horrible astronomers are at naming things.
Yeah, this is a continuing trend, but I'm kind of glad, like, it gives it some character, you know what I mean? Rather than the numbers that we're used to. Like, what was the pulsar you mentioned earlier today? B19, PSR B1919 plus 21.
Yeah.
Like, Truffle 50 is so much better. I'm not sure if truffle would apply. Truffle or praline. We can investigate further and figure out a new naming system.
Yeah. My favorite, I think, is the hot dogs.
Mm-hmm.
Gotta be my favorite. When I read that in a paper, I was shocked that somebody actually named them hot dogs, but I love it.
Yeah, and like spaghettification, like there's no other word that could perfectly describe it.
Yeah.
You don't need anything else. You can already picture what that process looks like.
Yeah. Oh yeah. Yeah. And also the green peas were very entertaining. That was the first paper that I read when I started my master's was on green peas. And it was really funny to just see the author refer to the galaxies as the peas through the entire paper.
Yeah.
It's very entertaining.
Yeah, we have, like, biologists are no different, but we have several genes that are named some pretty interesting things. We have a Sonic the Hedgehog gene, which is so wordy, but it is what it is. One of the genes, the gene family that I'm studying has 3 proteins, and it's Cyclops, Squint, and Southpaw. So everything's a little different. Of course, they have their proper names, which that's what I'll refer to them in literature. But I would love to just say, peas did this.
Yeah. It's definitely a good way to get people to remember them too.
Yeah, it makes it, like, you're going to think about that paper, like you said. That was the first paper you read when you started your master's. What other article can say that about themselves?
Yeah. Yep. Very interesting. So I'm always looking out for new ridiculous food related things that astronomers do, because it's just a running joke at this point. So this is definitely one of them.
We'll compile a list.
Yes.
And update it, and it'll be like This Week in History. A new spaghettification process was identified.
Yes.
This one's called fettuccine.
Oh yeah, definitely funny. Well, we have 15 minutes left, which is, I think, the perfect amount of time to discuss the amazing news, which, Gagan, I will hand this over to you.
I mean, is 15 minutes really enough? I feel like this could have been the whole episode.
Oh yeah, totally. But for a quick summary and this absolute necessary discussion about astronomers and food, I think 15 minutes, that works.
Yeah, maybe we'll be taking some food to the moon pretty soon, because the Artemis mission launched just under 2 weeks ago. So I'm not sure if you all heard that. Of course, I know all of you did. We did not have a York Universe last week, so we didn't get the chance to discuss this. But the Artemis mission is the first mission in our pathway to get back to the moon. So the entire Artemis program is a huge program, a collaboration by NASA, the European Space Agency, JAXA, CSA, which is, Japan and Canada respectively. It's a huge program that is building towards moon exploration. And the goal is to basically build a moon station and a lunar orbiting space station called the Lunar Gateway on the moon. So the goal is to get people on the moon, get a space station around the moon, and this will basically facilitate further missions to other planets. So Artemis 1, the very first mission in the docket, was launched on November 16th, almost 2 weeks ago. And over the course of last week, it reached the moon and it was getting situated into a distant retrograde lunar orbit. And right now, it's only robotic elements going up on the moon. So the Artemis 1 mission was the Orion spacecraft, which was launched on the Space Launch System. And it was a full test run, uncrewed. And there were 3 mannequins aboard, and they're called Moonikin, Helga, and Zohar. And they're on board with a bunch of sensors to test whether the Orion spacecraft is safe for crew, and as well whether its heat shield works, as well as whether the Space Launch System rocket is effective enough to get this mission in the air. So with the pending success of this mission, we hope to see crewed missions starting pretty soon after. Artemis 1 was scheduled to launch, reach the moon, and then enter a 6-day orbit before flying close by again and returning to Earth. So right now, it's still in orbit and testing different parts of the craft, such as the Orion thrusters and the star tracking alignment tools, which will be used for navigation when they're in mid-flight. And if everything goes according to plan, we could have humans on the moon for the first time in decades by 2025. And that's just over 2 years from now. I don't know if we realize how fast this is going on, but there's a spacecraft around the moon right now. And when it comes back down with its data, things will be in motion to have people on the moon real soon. And this sounds insane. We know pushbacks are almost inevitable because there is no room for error with crewed missions. We can't let any craft go up with any margin of uncertainty because these are people's lives on the line. Some of our best and brightest scientists, we do not want to be sending them up into space without 101 contingency plans. Everything needs to be taken care of. But by the 2030s, we might have a moon base situated on the lunar surface, as well as the Lunar Gateway Moon Space Station, which is going to be kind of a docking system similar to the ISS, orbiting around the moon, and that'll make missions to planets, namely Mars, much easier in the future because they'll be launching from lunar orbit rather than Earth orbit. So we can store equipment on the moon, equipment on the space station. Astronauts will be able to go between the Lunar Gateway Station, the lunar surface, and back to Earth. So it's going to be a whole big system. And Artemis 1 is just the first step. And I'm so glad it's in the air.
Yeah, it's definitely amazing that it actually finally went. It had quite a few delays, so I'm really glad that it did go and it was successful.
Yeah, with the Lunar Gateway is something that is still very much in the planning stages. I know that if everything goes to plan with the Artemis missions, they plan to have most of the Gateway station assembled in orbit around 2030. But I think the base on the surface of the moon will come prior to that. So Artemis 2 is probably going to be a crewed flyby of the moon. So basically the same mission that just happened, except instead of the mannequins, Moonikin, Helga, and Zohar, it's going to be 6 astronauts who will probably go around the moon. And then if that goes well, Artemis 3 will follow up a few years later with the astronauts landing on the moon. Some of them orbiting, some of landing, but it'll be a very exciting mission.
Absolutely. And I think there's going to be a Canadian on Artemis 2 and possibly 3.
Yeah, I think they already have Canadian astronauts on the docket, or space is reserved because of the CSA's contribution. The Lunar Gateway Station is planned to have the third Canadarm on board as its docking mechanism, so that'll be very exciting. And it'll also be, they plan to have the first person of color step foot on the moon, as well as the first woman to step foot on the moon. So it'll be a mission full of achievements across the board.
Absolutely. Definitely time that they went back there.
Yeah, as we were discussing earlier this episode, it's been so long since we were on the moon, like well over 50 years now, that there was no going further until we went back.
Yeah, I know some people have kind of asked, like, what's the point of going back to the moon? Why don't we just kind of go straight to Mars? But there's definitely a lot of advantages about going to the moon itself, possibly just in terms of like the scientific gain of studying the moon. There's still a lot to be learned about it. And I think one of the lessons learned during the Apollo missions is that there's really no substitute for sending a human that can think like a human onto the surface to gather data, of just sending a robot.
No, human research is the ideal.
Yeah, so there'll also be a lot of scientists going to the moon too. There was towards the end of the Apollo program, there was that scientist on the moon program where they did have scientist astronauts training instead of just pilots training to go to the moon. But only one scientist astronaut ever actually stepped foot on the moon, which was kind of a disappointment. And not to say that the work that the other Apollo astronauts had done on the moon, it was all amazing. There were tons of amazing discoveries that came out of it, and they did amazing work. But it was definitely kind of a disappointment that you go all the way out to the moon and you only have one scientist that ever goes.
Right.
So.
Yeah, and even nowadays, scientists or astronauts in general tend to be scientists.
Yes.
I think when I was looking into the CSA astronaut guidelines, because when's the next application cycle, CSA, I would like to apply. I believe it's a mandatory MD or a PhD.
Yeah.
Which is like, I can't imagine anybody getting up there without either of those things or both. So, it would make sense to have a doctor, a scientist, and a pilot all in one person where they can do multiple things, and then have everybody trained to that similar capacity. So, bar any mistakes or something happening on board, you still have a full crew that can run the ship.
Yeah.
Yeah.
Sorry, go ahead.
Go on.
Go ahead.
Oh, I was just going to say it'll be the actual base on the moon will open up a lot of opportunities for experiments happening on the moon and not just bringing samples back.
Yeah, I mean, imagine what you could do with an actual base on the moon, because all of these Apollo missions were a few hours to a few days on the moon. So really imagine what's going to happen with like prolonged humans sitting on the surface of the moon. It's going to be amazing.
Yeah, it'll be a camp.
Oh yeah.
And I also think they're setting up a telescope, which is great because you don't have to worry about the atmosphere, but you still have it kind of mounted on the ground.
Oh yeah, that would be awesome.
Yeah, so they're looking at several options for that.
Yeah, radio, or even optical or infrared telescopes on the far side of the moon. That would be amazing.
Yeah, you don't get any of the atmospheric interference. Basically all the benefits of a ground telescope with none of the drawbacks.
Yeah. That would be really, really cool. I hope they do that. I always hear about all of these plans and then get really excited and realize it's so far in the future. But
yeah,
Gotta start.
Sorry, go on.
You gotta start somewhere, and this is definitely a great start.
Yeah, I remember hearing your presentation on the whole Artemis program and the Lunar Gateway back in 2019 when we had the 50th anniversary event. And it was amazing to me at the time because you went through all the missions that had gone to the moon previously. And then this massive lull of time where we didn't have much. And then you presented this Lunar Gateway mission that was kind of in the early works. And I was like, I don't know if this is going to happen before the 40s. You know what I mean? Mm-hmm. But here we are. Step one is around the moon right now.
Yeah. Yeah. Oh yeah. Just time needs to speed forward a little bit.
Yeah. No, for sure. I missed the launch too.
Yeah.
So I wasn't able to see it live, but I really do want to. I want to go down there and see one in person because that would be incredible. But the amount of people that were there at the launch, I saw videos afterwards. It was insane.
Yeah. Yeah. The other thing that I would definitely love to go down for one, but I would like them to get through a couple launches where it's not scrubbed 3 times before it actually goes.
Yeah. I want a day one success. Let's go.
Yeah. And that was kind of the reason, because I missed the launch also. And that was kind of the reason, was because it was scheduled for like 1 a.m. and I had to be up early the next day. So I didn't watch it because I was figuring, well, I mean, there is a chance that they're going to scrub it. And I don't really want to get up at 1 a.m. and not be able to get back to sleep with that. But okay. I'm kind of kicking myself. Like I should have done it now because it was a really beautiful launch.
Yeah. The videos were incredible.
Yeah. Absolutely. Definitely need to go and see one of those live. It's the most powerful rocket in the world.
Since Saturn V, right?
I think it's got to be more powerful than Saturn V.
Yeah, but there's been nothing of that caliber since Saturn V. So yeah, it's been a long time. I know it was huge. It was like the first heavy payload rocket that they had set up inside the actual hangar facility at the location.
Yeah.
So lots of
building is amazing. It's so big it actually has its own small weather system in there. You can actually get clouds at the top.
The launch, like the building, the hangar.
Yeah, because it has to fit the whole rocket in the building.
Oh yeah, the VAB, the vehicle assembly building.
VAB, yeah.
Yeah, imagine snow in the VAB, but I guess they wouldn't allow that. That would be cool.
I don't think so, but yeah, it's pretty awesome. Everything at NASA is great.
Yeah, I was looking at it just now. It's the 8th largest building in the world by volume.
Yeah.
That's insane.
Mm-hmm.
And the largest single story. That is so funny. It's technically one story.
Yeah. Yeah, because there's the big hole in the middle where they assemble the rockets.
Yeah. No, it's great.
Oh, yeah.
Yeah, it wasn't... I have been to the Kennedy Space Center. But I wasn't able to see any launch. So we kind of just drove by the launch pad because when they're out of use, it's just land. But there was nothing around at the time. We got to see a Saturn V though. It was like I think they had one on display. A shell.
I need to go to the Space Center and see all of these things. You can apparently
do
instruments from the Hubble Space Telescope that were brought back down during some of the servicing missions.
Yeah.
And I had never realized how massive some of these instruments are. Like, they're huge. And you can see them in person for yourself, which is always very cool.
Yeah, I really want to visit Johnson in Houston because they have the planes.
Yeah. Yes.
Out with like the shuttle carrier aircraft, which is incredible. I really want to see that. And they have the craft, like the shuttle mounted on top of the aircraft.
You just need to travel all across the United States to the different space centers, and that would be fun.
Exactly. Yeah, road trip.
Yeah, absolutely.
Can we take the rocket? Kind of cut our travel time.
Yes. Yeah. All right. Well, we have officially reached the top of the hour. So, Gagan, would you like to send us out?
Yeah. So, everyone, you've been listening to York University Astronomy and Astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Sana and myself, Gagan. Stay tuned because it's Science Night in Canada. And you can always connect with us on Twitter with the handle @YorkUniverse and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in to York Universe, clear skies, and have a good night.
Have a good night.
AFM.
Look, being a host is never easy. All the prep work, the last-minute scrambling, making guests feel comfortable, it's a lot. When you're hosting for the holidays, there's no better place to start than at IKEA. Right now, at the IKEA holiday event, you can get everything you need to deck the halls and every room in your home with up to 20% off select holiday essentials until December 24th. Visit an IKEA store for full details.
This is a CBC podcast.
T-minus 10, 9, 8, 7, 6.
E is equal to mc squared, in which energy is
the human genome is our shared inheritance.
Cracks and cracks.
Hi, I'm Bob McDonald. On this week's show, rebuilding the cartilage in your hips and knees. Can a lesson from salamanders help prevent arthritis?
We're talking about potentially trying to boost a natural repair molecule when it's needed, say, for instance, after a knee injury.
And how much of the anxiety associated with autism is in the skin?
If you really think about it, it's not that surprising that if the way you feel the world around you is altered, this may impact how the brain develops and how you behave.
And a new prosthetic leg you can feel gives amputees new confidence in their artificial limbs.
The main thing was that they trust the prosthetic device.
But first, understanding humanity's continuing impact on nature. We've wiped out half of all the life on Earth. That's today on Quirks and Quarks. In the last few weeks, a protest movement has been spreading around the world. You might have even seen these protesters locally. It's called the Extinction Rebellion. And participants are protesting what they're calling an unprecedented global emergency. They say on their website, quote, "We have entered a period of abrupt climate breakdown, and we're in the midst of a mass extinction of our own making."
Extinction!